set of exercises in this video tutorial will provide a basic introduction to the use of the BioLuminate interface for displaying structures. The focus is on the toggle table, which is the primary tool in BioLuminate for interacting with objects in the workspace. So let us now import a protein to use as our example structure for this tutorial. Let's go to File, Get PDB. Then type 20T3 and click Download. Now that the structure has been imported, we can start with some basic operations. Using your mouse, hold down the left mouse button and drag it around to rotate the structure. Incidentally, if you want to reconfigure any of the mouse settings, just head up to Edit, Settings, Mouse Actions. Here you can customize any mouse settings you wish, including settings for a trackpad. Using the middle button scroll wheel on the mouse, you can adjust the clipping planes. And you can zoom in and out of the structure by holding down the right mouse button and dragging. You can then go ahead and click Zoom in the toggle table so that the structure zooms out and you can see all the visible atoms again. Now if we click Reset on the toggle table, the structure is reset to the original view. And if we click Orient, the structure is reoriented so that it is centered in the workspace and that the view is rotated so that the structure is most spread out in the plane of the screen. In the toggle table, there are two rows under entries in the workspace, labeled All and 20T3. Each row corresponds to a project entry, in other words, a structure. The All row is a special row that applies to all structures in the workspace. Each row has a set of buttons for doing operations on the structure. These buttons are actually menus. A is for Action, which performs various actions on the structure. S is for Show, which shows the structure or parts of the structure in different representations. H is for Hide, which hides various parts of the structures or its representations. L is for Label, which labels the structure or parts of it with various properties. And C is for Color, which colors the structure or parts of it with various color schemes. So let's illustrate some of these on the 20T3 structure. Choose S, Sticks. Now the bonds are shown in stick or tube representation. If we choose S as Lines, now the sticks are no longer shown and the bonds are represented by lines again. If we choose H, Waters, now the water molecules are no longer shown in the workspace. However, they are still counted as being in the workspace even though they are hidden. If we choose S, Lines, now the water molecules are redisplayed. The representation applies to all atoms in the structure and any hidden atoms are made visible again. Choose S as Ball and Stick, now the atoms are represented by balls and the bonds by sticks. Choose L, Other Properties, Stereochemistry, now the chiral atoms are labeled R or S. Choose L, Clear, to clear the labels. Choose C, Color by Element, then this custom color for carbon. This color scheme colors all atoms by element and applies a user-selected color to carbons. We can then use the color selector to choose a color for the carbons. Choose C, Color by Spectrum, B factors. Now the carbon atoms are colored according to the PDB B factors or temperature factors. Now, from looking at the status bar, we can see that this protein has two chains and hence an interface that can be displayed. So let's choose A, Preset, Protein Interface. Now the atoms in the interface region are displayed in ball and stick, while the rest of the protein is displayed in cartoon. Each chain is displayed in a separate color. So far the operations have been mostly performed on entire structures. To perform operations on part of a structure, you have to select the atoms you want to work on. You can do this by picking atoms in the workspace, either individually or as part of a group, such as a residue, a molecule, or a chain. So let's choose Edit, Pick Mode, Chains. And notice the cursor in the workspace changes from a box with a C next to it to indicate that you are picking chains. Now when you click on, or pick, atoms in the workspace, the entire chain that the atom is part of is selected. the atoms are marked with yellow boxes and a new row is added to the toggle table, labeled Selection. This is the row that you can use to perform actions on the selected atoms. For example, in the Selection row, choose S as Lines, and notice the chains that you selected are now shown as lines or wire form. Again, for the Selection row, choose A, Copy to New Project Entry. Now the chain is copied to a new entry in the project, and a new row is added to the toggle table labeled Selection 001. We can rename it by going to Selection 001 and choose A, Rename. We'll call it 20T3 Chain B. Back in the Selection row, we can choose the other chain by choosing A, Modify, Invert with Any. Now the selection is inverted. Then we can repeat the previous steps to copy this chain out as a new project entry. So now we have extracted the two chains from the protein into separate project entries. Each of these is included in the workspace as well as the original protein. However, we can remove the original protein by going to A, Remove from Workspace. And now we can quickly hide or show the two chains separately by clicking on their title. Finally, we can bring back the original protein that we removed by clicking the Include in Workspace button, which lists all of the entries in the project by title and entry ID, and then clicking 20T3. Notice that the entries that are already included in the workspace have the word included at the beginning of the row.